Question number 26. It says, use the given degree of confidence and sample data to construct a confidence interval for the population mean of mu. Assume that the population has a normal distribution. The principal randomly selected 6 students to take an amplitude test. Here were the following scores. And it says, note, the value of the sample mean is approximately 80.45, and the sample standard deviation is approximately 4.98. They were calculated for us already. At the bottom of this PDF, I will have the solutions, or rather the steps that I will take to showing that the mean is 80.45 and the standard deviation is 4.98. So you can feel free to read it just in case you're asked to show those steps on your exam. I'll also show you guys how to do the mean and the standard deviation in a TI-83, TI-84 calculator. So let's determine the 90% confidence interval for the mean of the scores for all students. And this is the formula that we're going to be using, the formula to the left. Some people prefer to use the formula to the right. That's okay. It's the same thing. But the final answer needs to be in the form of the sample mean plus or minus the margin of error. E is margin of error. So let's determine our values. The sample mean is 80.45 or approximately 80.45. The sample standard deviation is approximately 4.98. Our sample size consists of 6 students. And in order to find our T critical value for 90%, we need to first determine our degrees of freedom. The degrees of freedom in this case is the sample size minus 1. Because my sample size is 6, the degrees of freedom is going to be 5. Now to find our T critical value, we're going to open up the T distribution, 90% confidence, degrees of freedom 5, and determine that T critical value. Okay, 90% confidence, degrees of freedom is 5. The T critical value appears to be, my line wasn't straight, 2.015. Now let's compute our confidence interval. I'm going to go over here. The 90% confidence interval is going to be 80.45 plus or minus the T critical value of 2.015 times the standard error, which is going to be the sample standard deviation of 4.98 divided by the square root of the sample size, square root of 6. In the beginning, the direction stated to round all intermediate answers to 3 decimal places. That's what we're going to do. We're going to divide 4.98 by the square root of 6 and round the 3 numbers after the decimal. Okay, 4.98 divided by square root of 6. And we're going to take 3 numbers after the decimal. So let's do 2.033. Let's put that in parentheses. Let's bring down everything else. 80.45 plus or minus 2.015. Let's multiply 2.015 with 2.033 and take 3 numbers after the decimal from that point. So that's going to be 4.096. 80.45 plus or minus. Since the final answer needs to be in this form right here, what we can do is we can round the two numbers after the decimal. So 80.45 plus or minus. If we look at this 6, is going to round this 0.9 up to a 10. So it's going to be 4.10. Another way we can write the answer is 80.45 minus 4.10. And then we have 80.45 plus 4.10. So that's going to be 76.35. We have our mu and 84.45. And this is our confidence interval in interval form. So that can also be a possible answer. Sorry, my voice is a little bit lighter. I'm kind of losing it. Okay, let's answer part B. Part B says, find the standard error of the mean. The funny thing is, we already found the standard error of the mean. The standard error, rather the estimated standard error, is the sample standard deviation divided by the square root of the sample size. And when we did this for part A, we got 2.033. That's in blue. So we can do it again just to prove that it's 2.033. That's going to be the standard deviation of 4.98 divided by the square root of 6. Keep that in blue. And if we divide that again, that's going to be approximately 2.33. The margin of error, we also found that as well. That is what we had in red. When we scroll back up to the top, the margin of error is multiplying the t critical value with the standard error, and we got 4.096 when we rounded the two numbers after the decimal. So in order to calculate that, that's going to be the t critical value of 2.015 times the standard error, which we just found again, of 2.033. And we got approximately 4.096. D. How large a sample should be taken if the mean score for all students is to be estimated with 90% confidence to within 2 points. Assume that sigma equals to S. Okay. Because it says assume that the population standard deviation is equal to the standard deviation, equal to the sample standard deviation. And this is the formula that we will be using to compute the minimum sample size. For this case, we can rewrite this formula as the minimum sample size for 90% confidence equals to the z critical value times the sample standard deviation in this case divided by the margin of error, and that entire quantity is being squared. Now, we know that the sample standard deviation for this question was 4.98 when we rounded accordingly. In addition, we need to find the z critical value for 90% confidence. There is two methods we can employ when we're trying to find the z critical value for 90% confidence. we're going to access the t distribution, 90% confidence. And because we want to find the z critical value, we scroll all the way down to the last row of the t distribution. And down here is where all the z critical values are located. We see this value here of 1.645 for the 90% z critical value. However, this b right here can be related to this footnote, which is over here, that says this value has been rounded to 1.65 in the textbook. And that's the value that we're going to use, 1.65 for the z critical value. Now, if you're in my class, and if I choose to allow you to use this paper, this document on your exam, you can access what is called the z% table. We need to find the z critical value for 90% confidence. Confidence interval is here, 90%. That z critical value is 1.65. The margin of error for this question is different from the margin of error in part C, because the margin of error is the maximum likely difference between the point estimate, which is the sample mean, and the parameter, which is the population mean. In this question, we want to estimate the 90% confidence interval to be within 2 points. Therefore, our margin of error is 2 points. Now let's find the minimum sample size. N equals 1.65 times 4.98 divided by 2. And we're going to square this. And remember, when it comes to the minimum sample size, we need to round up to the next whole number. So 1.65 times 4.98. Divide that by 2. Then we're going to square this value. I guess we can put 4.1085 in parentheses. Square that. And we're going to round this to the next whole number. So n is going to equal to 17. And that is the answer to this question. And that is it to number 26. All right, guys. Hope that made sense. Hope you enjoyed the video. And I'll catch you in the next one. Take care.